Okay, today we're going to cover Unit 7, Notes number 2, which we're talking about our exponential functions again, but today we're going to talk about our shifts, so how it'll shift up and down on the graph. So to kind of review our exponential form, we have our first thing we have is our a value that's in front of our base, and our a value will stretch or compress the function vertically. And it will also reflect the function over the x-axis. So if it's negative, it'll reflect. If it's depending on what type of number it is, will depend whether it gets stretched or compressed. Then the d value, which is the value on the end, which we're going to talk about today, shifts the function up and down. And then the b value is our base. So going down to the bottom, it says use a table to graph the function 4 of x minus 5, then identify its key characteristics. So we first want to go to Desmos and we want to graph we want to plug it in so we can get our values. 0, 1, 2. Okay, and I believe I already have this typed in, so we're just going to put it into decimal form and we are going to round it. So we get negative 4.9. Negative 4.75, negative 4, negative 1, and a positive 11. We're going to graph these points on the line. So negative 2, negative 4.9, so over negative 2 down to almost 5. Negative 1, negative 4.75, 0, negative 4, 1, negative 1. And then 211 is going to be a little bit off the graph. So those are our points. So if you can see, it gets really close to negative 5, but it never crosses. So let's see if I can do this right. Our line is going to graze 5 and then go up. Negative 5, sorry. Y-intercept is at 0, negative 4. The horizontal asymptote is that imaginary line that it gets close to but never crosses. So it's going to be our y value, and it's going to be y equals negative 5. This is going up, so it is growth. Our domain, if we remember, is our x value, so this is all real numbers because it goes on in both directions on the x-axis. And then our range is going to be y is greater than negative 5 because it's only going to it's going to be bigger than negative 5. It's never going to hit negative 5. Okay, so kind of talking about our transformations. Our transformations always start with a y-intercept of 0, 1. So that's where our parent function will always cross the y-axis. So we have to think about, describe this transformation. So negative 5, that is what's different because this is our base. That's our parent function is 4 to the x. So the negative 5 is what's going to shift it. So the negative 5, since it's negative, it's going to shift it down 5 units. Oh, man, let me see if I can write. Down 5 units. If you say shift down 5, that's okay too. We shifted down 5. Next, it says write an equation of an exponential function with a base of 3 and a y-intercept of 4. So we know we are going to have y equals, our base is going to be 3, so 3 to the x. We just have to figure out if our y-intercept is 4, how far we shifted up. So if you remember what I just said, our parent function always goes through at 1. That's where our parent function always goes through. So if we need to get up to 4, we have to shift 2, 3, and 4. So we go 1, 2, 3. So we're shifted 3 up. So this would be plus 3. So you have to think all of our parent functions start at 0, 1. So how far did we shift up or down from that point? Then it says write the equation of a different exponential function that has the same base. So we just need to have the same base. So y equals 3 to the x. And you can just change your shift. So we could do minus 2. And that's different. It just has the same base. Okay, let's go on to the next page. So the next page, we are going to be stating whether these are the same or different. So our first step is we want to get kind of a graph for or f of x equals 1/2 to the x plus 2. So what we're going to do is we're going to plug that into Desmos. To the x, and then what was it, plus 2? Okay. So this is our function. So it looks like it has a y-intercept of 0, 3. And you can just click on that and it should give it to you. So let's kind of draw a sketch. So this goes, let's double check this. Oh, I did it wrong. So it goes through at 0, 3. And it comes down and over. Okay. So let's kind of compare a couple things. First, are our y-intercepts the same? Well, this one has a y-intercept of 0, 1. So clearly they're not the same, so they are different. Is our base the same? We're going to talk about that one later. Growth or decay, they are both going down, so they are both decay, so that is the same. Their domain is always going to be the same. Now this one is at y equals 3, and this one's at y equals 0. So their range is going to be different. That means if the range is different, that means their horizontal asymptote has to be different too. Because their range, this one's y is greater than 3. This one's y is greater than 0. So we have to keep that in mind. We're going to talk about the base later because we have to kind of use our points to find the base. But as long as you're able to identify whether the y-intercept is same or different, growth or decay, domain, range, and horizontal asymptote, that would be great. Okay, next one, we're going to do our matching graph. So again, we're going to put these all into the calculator. The biggest thing you want to look at is your y-intercepts and the points if they match up. So y equals 3 to the x. Y equals 1/3 to the x. Y equals 3 to the x minus 2. And then our last one, oh goodness, did not mean to do that, is y equals 1 divided by 3 to the, oh, not what I wanted. Okay, gets back to the outside, to the x, come back down, minus 2. Okay, so these are all of our lines. We got a lot of different ones, so let's kind of go through these. So our green line is y equals x. So this is the one that's going up and has a y-intercept of 0, 1. So we're going to go find the one that has going up. So the ones that we have, this one and this one that are decreasing, it has a y-intercept of 1. This one has a y-intercept of -1. This one has a y-intercept of 1. So this one would be our option for A. Okay, B. B is our purple line, so it's going down. Looks like it also has a y-intercept of 0, 1. So we have to find the one that's going down, which is going to be this one and this one, and it has a y-intercept of 0, 1. So this one has a y-intercept of 1. And this one has a y-intercept of 0, 1. So of -1. So it'd have to be this problem. Okay. And then lastly, we have our black one. It's going up, has a y-intercept of 1. Or a -1, sorry. Whew. So going up, y-intercept of 1, it would have to be this one right here. So this would be C. And then our last one is, it has to be this, but let's go double check our graph. So this last one is our red line. It's going down and it has a y-intercept of -1. So this one is going down, has a y-intercept of -1. So this one would be D. Okay, let me know if you guys have any questions over this, and you guys can get started on your homework.